I think I have to go for radius of gyration. Numericals completed. What was the last topic was? What was the last topic? Just check. Which one? Radius of. Okay. I have solved numericals, right?
Ma'am, could you invite Jonathan?
Jonathan?
Yes, ma'am. Thank you.
Ma'am.
Jonathan Thomas.
Hello, ma'am.
Yes, yes, Siddharth.
Yeah, the first period, no substitution teacher came, so I couldn't take the SFS
Okay,
program.
okay. Might be tomorrow in case if you have English period, you can move on.
Oh, okay, ma'am.
Thank you. Radius of gyration. Boys, please do right. Steve, you're not well. Steve, if you're not well, you have to inform. All, please keep your mask. Most of you children are putting your mask on your mouth, not on your nose. Right, boys. Radius of gyration. Now, what is radius of a gyration? So far, what we have learned is that, yeah, it's not seen because you can't see this. 1 second. 1 second. Can you see? Can you see the screen was just
Yes, ma'am, it came now.
okay. The moment of inertia tells you how fast, sorry, how difficult it is for you to rotate a body or how difficult it is for you to stop a rotating body. So if I have a rigid body which has n number of particles situated at certain distances from the axis of rotation, how do you measure your moment of inertia? You very well know I is equal to m1 r1 square up till mn rn square. This is what we have done. Now I can calculate the moment of inertia in a different way. I can calculate the moment of instead of finding m1, then r1, again m2, r2. This is a tedious process. So instead of that, what we can do is you locate the center of mass. You locate the center of mass. You're locating the center of mass. Let the center of mass be located for this irregular body. Let the center of mass be located at this point where the entire mass is said to be concentrated. This center of mass is at a distance of k from the axis of rotation. And this value of k, we call it as radius of gyration. Is that clear, boys? Instead of finding the moment of inertia in this manner here, you have to estimate what is M1, M2, Mn, then you have to find R1, R2. So it is a tedious process. Instead of that, what you can do is that you locate where the center of mass is going to lie, right? And see what is the distance of the center of mass from the axis of rotation. And that value k, we call it as radius of gyration. Then your moment of inertia is given by this formula, I is equal to mk squared. Now, how are we? Next is you have to derive an expression for k. Radius of gyration. Now, what is radius of gyration is?
Ma'am, should we write this?
Yes, the statement you write, boys. So what is radius of gyration? Radius of gyration is the distance between the center of mass and the axis of rotation. So the radius of gyration of an object is the perpendicular distance from the axis of rotation, from the axis of axis of rotation to center of mass. Otherwise, here the statement is to an equivalent point mass, or I can write to the center of mass. Instead of equivalent point mass, I can write center of mass. Instead of equivalent mass, boys, I can write the center of mass, so that both the moment of inertia is going to be the same. Boys, are you clear? So I and I should be the same, whether you calculate your I this way or whether you calculate the moment of inertia the second manner, both should be the same. Radius of gyration of an object, that is k is the radius of gyration. What is radius of gyration? It is the distance between the center of mass of the body from the axis of rotation, and that distance should be perpendicular. Now let us derive an expression for the radius of gyration, right boys? Expression for radius of gyration We'll start with this. What is the moment of inertia of any body? I is equal to m1 r1 squared. The moment of inertia of a body about an axis. What is that? m1 r1 squared plus m2 r2 squared plus mn rn squared. So what we'll do is we'll take all the particles. If we take n number of all these particles of equal mass, then what happens to m? Else I'll go for the next slide. What will be the moment of inertia of a rotating body? Just write moment of inertia of a rotating body about an axis. Why you are specifying about an axis? Why do you specify about an axis? I can write moment of inertia of a body. Why do you specify the moment of inertia about an axis? Suppose if I take a ring, right? If I'm considering a ring, if I consider the moment of inertia, this is a ring. For ring, if I'm rotating the ring about an axis which is passing through its center and perpendicular to its plane, the moment of inertia is mr squared. The same ring, if I'm rotating about an axis horizontal to its plane, I is equal to mr squared by 2. Its moment of inertia reduces. The body is the same. The body is the same, but your axis of rotation, the orientation of the axis of rotation changes the moment of inertia. That is why moment of inertia of a rotating body about an axis. Axis is very important. In which direction you rotate your body is important. You understand? And where is your axis of rotation located? Whether it is passing through the center or whether it is passing through the edge, even that is also equally important. Right, boys? So moment of inertia, what is the formula for moment of inertia? Steve. I is equal to m1 r1 squared, m2, okay, r2 squared, etc. up till, okay, etc. up till mn rn squared. Now let all these particles we have the same mass is equal to m. Let all the particles have the same mass. And what happens to I? What will happen to I? M into m into r1 squared plus r2 squared plus etc. up till. Are you getting this? You are making an assumption that I think I'm audible to the class 11B.
Yes, ma'am.
Yes, ma'am.
So you are taking all the particles to be of equal mass. So I becomes equal to m into r1 squared plus r2 squared plus rn squared. A slight modification will do. We'll multiply the numerator and denominator by n. What is n? What is n? Number of particles.
Number
What
of
is n,
particles.
boys? Okay, now n is the number of particles. N is the number of particles. So I'm multiplying and dividing the expression by n, which will not disturb the equation. Now, can you tell me what is the product of m and n represent? What will be the product m and n represent? M is the mass of each particle. N is the number of particles. Mass of the entire body. Boys, m is the mass of each particle. N is the total number of particles. So m into n gives you the total mass. Okay, now substitute. M into n becomes capital M. What is capital M? The total mass of the body. Please write what is capital M, what is small m. Boys, do specify. Capital M is the total mass of the body. Capital M is the total mass of the body. Small m is the mass of each particle. N is the total number of particles. Is that correct? Clear, boys? So now what will happen to your expression? What happens to your expression? It becomes m into n is what? Capital M. Capital
Yes,
M
yes.
into R1 squared plus R2 squared plus it goes on till Rn squared divided by n. Is that clear, boys? Are you getting this? Now, what we'll do is, let us put this entire expression as some value k, right? K squared, R1 squared plus R2 squared, etc. up till Rn squared by n. Let me take it as K squared because you will get the formula. So I is equal to mass into. So now then we'll see what is the value of K. So right, boys, this is all assumptions. You're making an assumption. So let K squared be equal to, what will be K squared? R1 squared plus R2 squared plus etc. up till Rn squared by n. Right? So what happens to your moment of inertia then? What will happen to your moment of inertia? Mk squared. Okay. Mk squared. So therefore, this K, what is K? The perpendicular distance between the center of mass and the axis of rotation. So therefore, your radius of gyration or gyration, different text follows different way. K becomes equal to, now you tell me what is the value of K. From this expression, what is the value of K, boys? Square root of? Square root of
I by n.
Okay, Rn squared plus R2 squared, etc. up till Rn squared divided by n. Is what? This is your radius of gyration. K is equal to square root of R1 squared plus R2 squared, etc. up till Rn squared divided by n. Now you have to define your K. How will I define? First, have you arrived at this expression? Have you arrived at this expression? Okay.
Ma'am, could you show the definition slide? I'll just put it in the chat.
First definition comes over here. How will I define? Can you identify this? It is a root mean square. What is root mean square? What does mean? Average.
Ma'am, mean
Boys,
means the average.
mean is the average because you're dividing, right, by n. N is the total number of particles. So average of what? It is a square root. Square root. Boys, are you clear what I'm from this expression, boys? This expression k is equal to square root of r1 squared plus r2 squared, etc. up till rn squared divided by n, right? This expression I'm putting in terms of statement, right? Can you, what comes first? Square root comes first. Okay, square root of what? Root mean square, because it's the mean of what? The square of the distances of the particle from the axis of rotation. What is R1? What is R1? What is R1? Distance of particle M1 from the axis of rotation. What is R2? What is R2? Distance of particle M2 from the axis of rotation. Boys, can you be able to identify both the statement and the statement and the expression? Can you correlate the statement and the expression? Look at the expression. It is the root mean square distance. Why square distance? R1 squared, R2 squared. So this is the definition for your radius of gyration. It is the root mean square distance of the particles of the body from the axis of R1 is the distance of the particle M1 from the axis of rotation. R2 is the distance of the second particle from the axis of rotation. So radius of gyration we have completed.
And could you show
Ma'am,
the
could you tell the
definition?
introduction?
Yes, what? You want me to explain this one? Like statement? Do you want me to explain the statement?
The introductory statement for the derivation.
Definition.
Okay, you complete this, then I'll go for the previous slide, boss. Shall I go for the previous slide? So there are two ways of expressing your radius of gyration. It is nothing but the distance of the center of mass from the axis of rotation. How do you measure your radius of the gyration? You measure your radius of gyration by finding the square root of the mean of square of the distances of all the particles from the axis of rotation. Are you clear? Next, we'll go for, right, boys. Obtain an expression for the work done by a torque, hence write an expression for the power. Obtain an expression for the work done by a torque. So when a torque is applied on a body, the body begins to rotate, which means we say the work is done by the torque. And you have to go for writing an expression now look at this, boys. Right? Consider a rigid body rotating about a fixed axis. Point P on the body. So you're just considering a point P on the body, which is rotating about an axis perpendicular to the plane of the page. How will it be your axis of rotation? Your axis of rotation? The body is moving on this plane. This is your monitor is your XY plane. The body is moving in an XY plane. Your axis of rotation will be passing to the point O and will be perpendicular to this plane. The particle will be moving above the axis of rotation, right? So if the body has to rotate, you have to apply a tangential force. You have to apply a tangential force. So when you apply a tangential force, the particle moves from point A to point B. You're applying a tangential force so that the particle P of the body moves from point A to point B, so that the angular displacement is d theta, linear displacement is ds. The body is rotating and the body rotates, right? It has linear velocity, it has angular velocity. So when the body moves from point A to point B, you're applying a tangential force. You apply a tangential force so that the particle moves from point, which particle? Particle P moves from point A to point B. So it undergoes a linear displacement ds and it undergoes a angular displacement d theta. So then what will be the work done? Work done by the torque. What will be the work done by the torque?
Work done
What is
will
work
be
done by a force?
torque into d theta, right?
Correct. What is the work done by any force?
Work
F
done is
into
force into the displacement.
displacement.
Displacement
Right,
is d
correct,
theta,
correct.
and
Correct,
force is a
correct.
torque.
Okay. Here, what is the work done? Sorry. Here, it's rotational motion. What will be the work done?
Torque into d theta.
Into d theta. Because you have to correlate. This is linear motion. Was in linear motion, the force is F. Displacement is linear displacement. This is rotational motion. In rotational motion, it is the torque. In rotational motion, instead of force, you have torque. Torque into what should be there? The displacement. Sorry, displacement should be not linear displacement. Angular displacement. What is torque? Torque is the force which causes a it produces a rotatory effect, but the torque can be measured as force into the perpendicular distance. So this torque will produce an angular displacement. Your linear force produces linear displacement. F is the linear force. Linear force means force when the body is moving, undergoing a linear motion. So F is the force which produces a linear displacement S. Here, you apply a tangential force. This force produces a torque. This torque makes the particle to rotate about an axis, right? Rotates, and the angular displacement is d theta. So let us find what is the work done by the torque in displacing the body from A to. No need for the statement, boys, because we are only just write. You want to write? If you can write, write box, otherwise it will be tough for you. Let us consider rigid body rotating about a fixed axis. I think rotational motion, you are not getting the concept, boys.
Ma'am, here ds is displacement in the diagram.
ds is linear displacement, d theta is angular displacement.
Okay, ma'am.
Boys, once again, go through all your torque. What is torque? See, what is torque, boys? The best example is opening the door or closing the door, right? Now, what is torque? A torque is one which produces the rotatory motion, right? When you're opening the door or when you're closing the door, you're making the door to rotate. Now, where is your axis of rotation? It passes through the hinges here. Now, where do you apply your force? You're applying your force on the handle. Okay, in which direction do you apply it? You apply the force perpendicular to the plane of the door. Yes, sir. You apply a force perpendicular to the plane of the door. So what is torque? How do you measure torque? The torque is how much force you have applied and the distance between the axis of rotation and the point where you have applied the force. Right? So that is torque. If you put near the hinges, will you be able to open the door? Because the perpendicular distance becomes equal to 0. So then whatever force you have applied will produce a 0 torque, then the body cannot rotate. If the body has to rotate, there should be a force applied, and this force applied should be at a certain distance from the axis of rotation. So torque is a force which produces rotatory motion, and this torque is nothing but the force into the perpendicular distance. Right, boys? It produces a small displacement ds on the body. So the work done by the force dW is equal to F into ds. Now this ds you need to, because I'm just drawing this. So this is a ds. This will be your radius vector. This angle is d theta. So what is d theta? What will be d theta? Arc length by the radius.
Yes, ma'am.
Okay. So d theta is ds divided by r. Correct, boys? So then what is ds? R d theta.
R d theta. Yes, ma'am.
So that you are substituting over here, boys. Correct? So R,
Yes, ma'am.
R d. So what happens to your work done? I think so. It's better me to write. I'll just do this. So this is dW is equal to F into ds, correct? Fine, boys. So then in that case, if I go for this, this is d theta, this is ds, this is r. So what is d theta, boys? D theta is equal to ds by r. Okay. So therefore, what is ds? ds is r d theta. Correct? So that you are substituting over here. So therefore, dW becomes equal to F into R d theta. Correct? What is F into R? Force into the perpendicular distance from torque. R is this. The perpendicular distance, yes, boys. So dW is equal to tau into d theta. So this is the work done. What is dW? It is the work done by which force? The tangential force in moving the particle from point A to point B, so that it undergoes a linear displacement ds. So then what is the power developed? How do you define power? How do you define power? Power is rate of doing work. What is power, boss? How fast you do your work. That is power. Rate of doing work means what? How fast you do a work is power. So power is rate of doing work. P is equal to dW by dt. So what is d theta by dt? Theta is angular displacement. D theta by dt is rate of change of angular displacement. What is that? Angular velocity omega. I think so. I'll make all the formulas to be written once again. Children are confused. Okay, boys. Shall we write all the formulas, or you will take care of your formulas? Just tell me before I go for the next one. Shall I make you to write all the formulas? Okay, just you write, boys. I should not ask you.
Ma'am,
Yes.
all the formulas in the middle of the chapter, like, would not be suggested. Yeah,
Difficult.
because
Okay.
yeah. So can we
Fine,
just
fine.
write all?
Fine. Yeah. Yes, boys. You are clever enough. I may not interrupt. Right, boys. Law of conservation of angular momentum. Fine. I'll do it the moment we'll start. Fine. Law of conservation of angular momentum was very, very, very important concept. Please, all your reasoning based question, all your numericals are equally important. Clear, boys? Fine. Now, I think so. Some of you might understand. It's 11C. Now, what is conservation of angular momentum? Did I show any video clipping long back? No. Conservation of angular momentum was, did I don't know whether I have deleted it. 1 second, boys. I'll just see whether. I have deleted, I don't know. One second. So, let's just check.
Hi, my name is Mike Fossum. I'm the commander of Expedition 29. Welcome to the International Space Station. You may wonder why the
1 second, boss. You can hear?
Yes, ma'am. Yes, ma'am.
Hi, my name is Mike Fossum. I'm the commander of Expedition 29. Welcome to the International Space Station. You may wonder why the International Space Station doesn't tumble in its orbit around the Earth. Well, we have a system that maintains our attitude control system, if you will. There's really two ways to do this, to approach it. The first way would be to use rockets or small jets that would keep thrusting and pushing to nudge the space station into its correct attitude. Problem with using thrusters like that is it requires a lot of fuel that we have to continually ship up from the Earth. So instead, we use angular momentum and gyroscopes. Let me demonstrate a little bit. Before we get into this, we really have to talk about the definitions of the concepts. It's really the conservation of angular momentum that's really important here. I have this flashlight rotating. In physics, this angular momentum of an object rotating about some reference point right here in the middle, that's a measure of the extent to which the object will continue to rotate around that point unless it's acted on by an external torque. Now, torque has to do with the ability of a force to rotate an object and how far away from the center that force is applied. The angular momentum of a single rotating body is equal to the product of its rotational inertia, that's just physical properties of the mass distribution, the rotational inertia, and angular speed, how fast is it moving. The angular momentum and rotational inertia, that includes the mass, are constants in the system. Angular momentum of the system remains constant if no external force is acting on the system. This is the law of conservation of angular momentum. I can demonstrate this to you with me actually doing a little bit of a demonstration here. So I want you to watch this. I'm going to have to unclip the microphone or I'll tie myself up in knots. Again, what's going on as my body spins doing this and moving my arms in and out from being close to the body is when I bring the arms in closer to the body's rotational inertia is decreased.
Did you understand, boss? When he's bringing his arms closer to his body, his rotational inertia I is equal to mr squared. What is R? The distribution of mass from the axis of rotation.
Yes,
Boys,
ma'am.
what is R?
Yes,
R is the distribution of the mass from the axis of rotation. How is the person rotating? He's rotating about an axis passing through him. So when you stretch your arms, when you're stretching your arms, the mass of the body is distributed far away from the axis of rotation. I is equal to mr square, right? Which means R is going to increase when you're stretching your hands. When you stretch your hands, the body's mass is distributed away from the axis of rotation. So R increases, moment of inertia also increases. But when you're bringing both your hands closer to your body, then the distribution of mass, I understand, boss. Distribution of mass from the axis of rotation is decreasing because you're bringing all the masses closer to the axis of rotation. So then when R decreases, moment of inertia will I is equal to mr square. I is equal to mr square. What is R? R is the distribution of mass from the axis of rotation. So when you're bringing your arms closer, you're decreasing the value of R. When you decrease the value of R, your moment of inertia will decrease. This much you understand. Tomorrow's class we'll see then why the speed is angular speed is increasing. You need to learn was because this is one of important difficult chapter. You can leave because you can leave. Please go through the chapter. Now it's a break for you boys.